Hey everyone, good morning. It's me, Yuri, and we are streaming again. How you doing? Let me know how is your Sunday morning. How's everything going? Hope it's good. Hope it's good. Yep. So today we're gonna be live coding something with the Pixy Js, but it doesn't really matter what the render pipeline we're gonna be using because it's mostly about just a bit of a math. Yeah. So just let me know if you can hear me well. Yeah, tell me something. Come on. This is gonna be the website we're gonna be live coding. You can see it's right behind me. This way. Maybe this way, I don't know. Hey, привет. Доброго ранку. Perfect. So it's gonna be this website today. I'm gonna try to replicate it because like once I saw that the spirals, I love the spirals, especially logarithmic ones, and this is just one of those. So let's do this. And just a fast heads up, I have a Patreon. If you want to support me, go ahead and support me. And yeah, switch the screen and get started. Okay, I'm gonna create the folder. I'm gonna call it Golden Spiral because this is Golden Spiral. And I'm gonna grab it here. I'm gonna create the HTML. I'm gonna replicate the Pixy Js class template again. And I'm gonna share it probably as a boilerplate for future streams for my Patreons. Golden ratio, right? Yes, right. It is golden ratio. And it is a spiral and it's beautiful. And you can see it always fits into the screen and fits beautiful in this small boat right here, which kind of travels through the city. And you get this, what's that? Amsterdam, I think, vibe from this immediately. Or probably any other old European city with a river, but still, it's kind of beautiful website. I really love that. Love at the first sight. Hey! So yeah, we're gonna try to replicate this one because for me it wasn't that obvious how you can do this. It looks so cool, but maybe it's shaders, maybe it's something else, I don't know, some curves, some stuff. And then how would you fit the spiral into the screen so it always fits into the screen, because it's kind of hard actually to do that. Yeah, you're welcome guys. All right, so I'm gonna really fast do the Pixy Js Boilerplate. This is probably the last time I'm gonna do this, and for the next streams I'm gonna be using it already. F.js. Oh, how do you do that? I will never ever remember the right way of importing Pixy Js or any other library. Yeah, so just really fast doing the boilerplate part. I'm gonna copy the initializing part from my Pixy. It's gonna be this app, and then nothing interesting so far. I think this just has to window thing, so I don't need to do this. And then document body pants set view. Then I would need the app ticker thing. So far, so good. Gotta be alright. Background, resize to, resolution, pending. I need to run this. So we should probably see something now. Yeah, we see the canvas. Gotta do the boring stuff. Yeah, it's all good now. So then I'm gonna just add some dummy stuff. This is kind of the basic structure that I have in my mind. Something's rendering, something is adding to the scene. This is as simple as that. And always create class because, well, sometimes those sketches might become the, actual production code, and I would need to import it into my library and whatever, and it's kind of easier to have it already in class, so you could have everything encapsulated there and just import the class. So to add something, I think I'm going to use the thing that I've seen in Pixy, like a real simplified version of adding the field with color rectangles. Let's continue Pixy sprite, and then you have to use the keyword. It's Pixy texture white. And then you can tint this. So you can do, so this has got to be a red one. And I'm adding it. I think I need to specify the sizing part, height and width. Not yet there, because why? Please contain add child. This is not add, this is add child. Yeah, so kind of this is I think the basic version of Pixy.js template, which apparently is not on the Pixy Js website because they have like some different kind of demos, more complicated maybe. The ones they consider it more useful, but I'm gonna just save this for future usage. I'm gonna call it Pixy Boilerplate, so I can use it. Maybe I'll add some image load in there or something like that. Otherwise, it's working good. Okay, so where do we start? We got the basic Pixy.js template. I think the delta should be here. Oh yeah, it should be the same, yeah, because it's delta, it's not the time. Maybe I would add the time. Like a generic time in JavaScript. Yeah, time is passing by now. All right. So where do we start? Oh, thank you, guys. Thank you for the kind words. I'm trying. It's kind of hard to do this every freaking Sunday because it's like doing something every Sunday is like doing something every hour or every 10 minutes. Not every hour I feel the same. Some hours are just not the ones you wish someone would see you. Okay, just like this Sunday. All right. So a couple of things here are going on. First of all, we have this river going on a spiral. Second, we have those lines like this generic golden ratio. If you Google for golden spiral Fibonacci, you'll get those things, right? If you go to the Wikipedia article, you see this wonderful spiral and kind of hypnotized me. The funny thing about those spirals, especially logarithmic ones, it's actually impossible to see if they are being scaled or they are being rotated at this moment. So this is the thing. Lots of GIF makers are using them for this specific effect because it's kind of hard to, it's kind of a quite beautiful illusion. So the generic formula for all the spirals are somewhat like this, or if you can use the polar equation, is the radio is equal to something and then exponentially grows, something that exponentially grows with the angle. So angle grows linearly and then the radius grows exponentially. This is what you call a spiral. And this specific spiral with a golden ratio, it kind of has to do with that golden ratio number, which is 1 plus something, but let's get to that. So this golden ratio means actually that this value, like this whole value, proportion to this, is actually the same as this to this, and essentially that means something like this, that p to 1, so let's say one of the sides was 1, is equal to phi divided by phi plus 1. So this is the actual golden ratio thing going on. Oh, maybe it's the other way around, sorry. So it's 1 to phi is the same as phi to phi plus 1. Is it right though? Okay. So let's just unwrap this one. So it's gonna be phi squared equals phi plus 1. Right? Yes, right. And that means that phi squared minus phi minus 1, this is completely wrong to do this in Visual Studio Code, but still, equals 0. And this means that because this is just a generic quadratic equation, we can get this number, and it's going to be, we need to calculate the discriminant, and the discriminant is going to be this squared minus 4, so it's going to be actually 5. The discriminant is going to be 5 because it's going to be 1 squared plus 4 multiplied by 1. And if you calculate the solution for this one, so it's going to be 1 plus sqrt, 5 divided by 2. So this is it. This is how you get these golden ratio numbers, just the solution for this thing. And the funny thing also, if I subtract 1 from this, I will still get kind of the golden ratio, because if you're using this number and if you're adding 1 to it, the proportion stays the same. It's just that it was to 1 to phi, and then it becomes phi to phi minus 1 or phi plus 1. In this case, minus 1. Yeah, so let's calculate this one, because I don't know if this math was, if I was clear with this math. It's kind of, you can just check out the Wikipedia article. It's gonna be 0 divided by 2, and then you can okay, I don't need time. This is the value. I wonder if I Google it, will I find something? Yeah, probably I was right, because the results are all about Fibonacci sequence. Well, it's hard to be wrong in here, it's pretty famous anyway. So we get this number, And now what I need to build those lines. So let's start by building those lines. Honestly, actually, when I built them, when I finally did that, and I struggled a lot with that, it actually turns out I could as well just use an image, just a PNG to fit it for the whole screen, maybe even in CSS, not even in Pixy.js. It just doesn't really matter in the end. But if you really want to do that, well, we gotta use some Pixy graphics. Yeah, that's true. I think the people who are really obsessed with it, they're not actually mathematicians, because if you learn math, you know that there are some pretty cool other numbers in math. And this one is just, okay, yeah, it's cool, but there are some other cool things happening in math. All right. Let's build the lines. Again, you can just use an image for that. When I finally did that, and when I decompiled the way the guys did that, I actually learned that, well, it didn't really matter at all. And this stream is kind of going to be cut in some corners here. So first of all, we need to get some context. Just like in a generic Canvas 2D environment, there's some way to draw lines and some primitives. And it's going to be new Pixy graphics, I think. Yeah, that's right. Then I can do something. I'm gonna probably do the layout for now. So we could see everything. It's kind of a simplification, and because I really loved math back in school and university, well, and I still love math currently, I kind of love to see like where it comes from. So it's not really just a magic number, so it's just a solution to some equation, and you can always get it yourself. You don't need to remember that or anything. If you forget the variable, you could just get it yourself. And this is the way I think. Because I really don't remember a lot of things about three.js and Pixy.js, but I just know where to find them and where to get them and how to get there. Yeah. Add lines. Add lines. We have the context. Now I need to have the line style. I think Pixy line style. Yeah. So Pixy line style takes a couple of. Come on. Line style. Sometimes I find the docs on Pixy a bit frustrating. So yeah, there are some line style, but this is not the line style I was looking for. And this is again not the line style I've been looking for. So I just need to find out like what are the variables it is accepting. Okay, so it's width, color, and alpha. I think, yeah. Line style, width, color, alpha, and then something which I don't need. Let width 2, color be red for now, and the alpha be 1. Now I can do the same thing that I do in generic Canvas. And then I need to add these graphics to my container, yeah. It's kind of not really context because I'm adding them into the container, but it's kind of an object. Yeah, so I can draw lines now. Okay. I need to get back from my Pixy.js doc quest. Yeah, so the lines are being drawn. That's all right. Now we need to find out where to draw those lines. Yeah. Where do we start? So it turned out actually I've tried to make a loop for that. some recursive, beautiful loop to draw those squares and those circles. So what I'm trying to draw now is this spiral and then those lines. And the thing is, there's one thing you need to learn about that. I think there gotta be some mention of that in Wikipedia website. So actually, those gotta be squares, right? Because this is a golden ratio thing and all that stuff. But this thing is a spiral. But you can approximate this spiral with just an arcs, just the usual arcs, and it's going to be kind of close approximation of the spiral. It's not really a real spiral. If I withdraw the real spiral with those arcs, it's not going to be the same. But Fibonacci spiral approximates the golden spiral using quarter circle arcs inscribed in squares derived from Fibonacci sequence. So actually, we could find out each square, then draw the quarter arc of the circle, then find out next square, draw the quarter arc of the circle, just the quarter of the circle, I guess. Yeah. And then repeat and repeat. I'd be honest with you, I wasn't able to come up with like this generic formula. I believe it's gotta be there, but let's do the first part at least. So first of all, I need some numbers. So let's on each step we're gonna be moving either from left, from top, from right, or from bottom, closer to the center. So I'm gonna start with the last right position, which is gonna be just this width. Then I would need the last bottom position, which is going to be this width. And I need something bigger than my height. So probably I need to go to the bottom because you can see this arc. So I need to get to the bottom of this. So this is going to be not divided, but I think multiplied by this p. Yeah. And this brings me to the bottom because this phi is greater than 1. So this is going to be greater than width. So it's going to go to the bottom. So definitely on most of the screens, it's going to fill the whole area. And then I'm going to just try to draw. Let's draw ctx 0 plus bottom. Is that right? Yeah, I think so. And then we're going to be moving to last right, last bottom, to the right. Except it's going to be line too. Maybe I should divide. Yeah, so we get this line. It's exactly the same position as the original website. Yeah, so the line needs to be here, but the circle is gonna go further. So last bottom, then I need to add the arc. So to add the arc, I'm gonna move my drawing tool back to the last right, last bottom position. And then I need to draw the arc. And the arc is Pixy graphics arc. So arc accepts the XY coordinates, the radius, and then start end angle, and then the anti-clockwise even thin. Okay, that's kind of cool. So I need the arc to be this ctx arc, this place, probably. Yeah, so I need to start it there. Then I need to go it from the radius is going to be this width, because the radius is gotta be this. and it's just this width for now. And then yeah, so we drew the circle, and I think it's gotta be, no, it's not right. I think it's one p back, so it's like this. Yeah, we got the circle. Okay, I'll remove the redundant stuff. So we got the first circle and the first line. Okay, let's move the second. The last left position, which is going to be just the last right, again divided by this p. It's going to be right divided by this p. I'm not going to go all the way deep, just another step, just to see how it works. So we'll get this last p position, and then so it's going to start in last left 0, so it's this point at the top. So we just got the this value by dividing last right by phi, because last right was just this width. So we got somewhere this point on the horizontal axis. Then I could do this last left to the last bottom, except it's gonna be line 2. Yeah, we got it. And then I need to add another arc. This one is gonna be not this, but like p from 2, and the center of this arc and the radius gotta be smaller. So the radius gotta be this value, and this value is just the last left. Yeah, now the center, and the center, yeah, so we got this arc. You can see how it starts to build up this spiral. It's not actually a spiral, it's just a series of arcs. And actually you can make a loop. Might be homework, might be an interview question. I've tried to do it myself, but it turned out to be like it's that case when you make a loop, it's actually kind of more complicated and harder to understand than if you just write in the dump code. So I actually wrote the dump code for myself just to continue this thing, and I believe the guys did the same. So I just replicated this procedure for a couple of steps, and we don't need a lot of those, like maybe 6 or 7, something like this. And yeah, I used these graphics there. It's just grab only the important bits. Yeah. Just replace everything. Yeah, this has got to be right. Then let's just copy paste this stuff. Let's cross our fingers. Nothing is working because why? A child of undefined. Oh yeah. Still something is wrong. What's wrong now? I'm just copy pasting the code and it's still wrong. Oh yeah, I used this e variable there, which is actually gotta be this p. And this e is undefined and I'm not getting anything. Talking about being consistent with your variable names. Not about me. Yeah, so here we go. we got this spiral. I think it's just, you know, I just replicated this step a couple of times, each time dividing the thing, and then for some steps I would need to subtract something because we would need to go deeper. We are getting deeper. It's not the border anymore. We need to find out these x, divide them, multiply them, subtract them, and all this stuff. It's kind of boring. I believe there's a pattern here because every step kind of repeating itself, but you need to walk into 4 directions and the variable depends on 4 directions, and it's kind of complicated. It's complicated for me. All right, so we got this. I'm gonna switch the color now, maybe to something more plausible, something like this. And I'm gonna change the background to white. Don't forget about this. So now I need to add this spiral. Hey, to London. I kind of feel embarrassed speaking English to someone watching me from London because I'm not a big fan of my English myself. Okay, so now we need to draw the parts, draw the other parts. How do they do that? Okay, so the spiral was kind of an easy part because we just drew the spiral. We could have used an image in the end, right? We could have just used a JPEG or PNG over all this whole stuff. But it's interesting to see how the pattern emerges. And then if I go to the network, let's see the images the guys are using there. So they actually have those as sprites, and I'm just gonna grab them, open them in Photoshop. Then I think I'd better start with the river also. So I need the city, of course, but I start with the river. So they compressed everything into sprites. I'm gonna grab the river. There are a couple of rivers, and I believe they made that because to make it more smooth. We'll see that quite soon. So now I need to get the exact river sprite. I'm gonna use one for simplicity. Golden spiral. Need to have less folders on my desktop, so it's gonna be a river. And then I have the city. Then I make it. I did that. And then the city. PNG. Now I could use them here. Import city from river PNG. Now to the interesting parts. So now I want to make a function get river, which is going to be just returning me the sprite. Need to close this one. So it's going to be kind of the same. Get river. Pixi sprite from city. So here I'm gonna just add river, get river. And just to check it's working. Okay, I have sprites. Something is wrong. Get river is not defined, of course. Yeah, so we have it now because I still have this tint. You can actually see how the tinting is working in the Pixy JS. So I can just tint every single sprite to some color and get it. This is the wrong one. I don't need tinting here, but it's kind of beautiful. It's a bloody city. Okay, so now we have this city, but it's kind of it actually fit kind of into the spiral, but it's definitely not there yet. So how do we do this now? The next thing I want to do, I want to get those squares. I want to get them right. So I want to get some, I want to be able to find out the coordinate of each square and draw something inside of it. To do this, I think I would need to get to the center of my spiral, and this is the hardest part actually. It was kind of hard for me to understand that and then to work it out into this, into the I'm getting river and then it's city. I want to see river. Yeah, this is river. It actually fits perfectly. How come? All right. So I need to draw those squares. How do I draw them? So let's just go ahead and do the add stuff. So add it just for testing purposes, and then I could just do the which formula I mean, but this is the most famous spiral, so it's kind of easy to guess. Yeah, well, actually, this is the point where you might know the better way to know this, how to get this, maybe with the quad tree or something. I actually am not familiar with the quad tree algorithm. Well, I know what that is, but I don't actually know how to fit it into here, because later I would need to rotate all this stuff also. So I need to get the center of this coordinate. By the way, I would eventually need to find out the center of those coordinates, and you can kind of repeat this algorithm like with the lines and just get the last bit, like and then and I'd get this number. I think I continued the algorithm a bit further, and the number was for me, yeah, kind of actually it was the same number, I guess. So this number is like the center, something like this. We're gonna fix it later. So this number actually tells that this aspect ratio to the whole width is actually this number. It's not the golden ratio or anything, because this number pops up because we need to fit this whole spiral into the screen, because we need to fit it exactly from the left side to the right side, and that's why this number pops up. I think you gotta have a way to get this. It's you gotta have to derive it somehow from the golden ratio itself, but I just well, I just measured it. So this is the number. Maybe it's an approximate number, of course. I believe it's got to be rational, but still. So it's kind of actually interesting if somebody knows how to derive that number mathematically, not just measuring the stuff. It's got to be very interesting. I actually don't know how to use quad tree, so if you know, just send me JS fiddle. Gotta be useful for everyone. Okay. Where do I go next? Where do I go next? Add stuff. So first of all, I'm going to calculate the center. Center x is going to be equal this width multiplied by this center, and then the center y is going to be equal this height multiplied by this, not height actually, also the width. So I'm going, on the add stuff, I'm going to just really fast add the square to see if it fits into the, Where's my dummy stuff that I just left in my Pixy boilerplate? I need this kind of stuff. Don't want to look at this anymore. So I want to put some red square, maybe small one, to this position just to check if it's really the center. So width center multiplied by this p. Nowhere to be seen. No errors either way, but maybe, yeah, it's just sometimes you need to divide instead of multiplication. So yeah, it's actually the right thing. It's kind of the center of this spiral, and I get it now. And I can maybe rotate this one now. But if you see closer to the website, the sprites, the city is rotating, but the spiral stays in the same spot. So I think I need two containers. And then I'll go here. Container. I need to get here, right? So everything should be the same except that rotation part. All right. So we're not rotating anything yet, but I needed to get to the center of the stuff. I think. I needed to get to the center of the stuff. Feeling kind of dumb, sorry. So we got the center. Now I need to get the squares. Now I need to get the squares for each of these parts. How do I do this? I think I'll need to have a loop for that, because I obviously need a lot of those squares. Lock position set. So this is just the dump thing to check everything is in place. Then I need to have a loop. Hello, Vaxu. It's gonna be loop for one element yet. So I'm gonna be adding something there. Probably need another container. Add child container. And in this container, I want to put something like this square. Like this square I just put. So just do the get block the dump stuff for the square yet. And I'll get this. Kind of a lot of ways at the same time on how to do next step, and I'm overwhelmed a bit. So just did the dump stuff to return the square, and then I need to have a loop to make all those squares, and they gotta be scaled and they gotta be rotated. So on each step I need to rotate them by 90 degrees actually. So let's go ahead and make the calculate this angle first of all. So the angle is gonna be equal y multiplied by math pi divided by 2. So this is gonna be the angle we're gonna be rotating each square. Then I'm gonna get the block, get this block, and then I want to put this block in my container, but there are a lot of buts. What's going to be the size of this thing? I believe it's got to be this width divided by this t. So because this is the first square that I'm getting is this one, and this is this width divided by this t. And then the height would be the same because it's a square after all. And then I'm gonna edit container, my block. And then I would need to rotate it, but let's just see if anything is working at all. Something is wrong because get block is not defined. Still something is wrong. I is not defined. Still something wrong. What the hell? Index is not defined. Yeah. Yeah, it's right now. So actually put this square exactly where it belongs. But what about the next square? If I just rotate this square, let's say I'm gonna rotate it, I'm gonna add 2 of them. And I will add the rotation too. So I'm gonna add bl rotation equals angle. I don't see anything. So it's kind of rotates, but it's wrong. It rotates not around the point that I need to. So I want this square to be rotated from this point. To do this, well, there are actually pivots in Pixy.js, but I think I wasn't. They're not clear to me how to exactly use them for this purpose. So the best way I found, I actually need to put the container into the center. And then put the sprite back into its position. Except it's going to be with a minus. So it's kind of look the same for now, but the thing is I don't need to rotate the sprite anymore. And I would need to rotate the actual container. This starts to look kind of what I expect it to look. Yeah. So yeah, squares kind of rotate in the right way. They're rotating around the center of the spiral now. Maybe I could do the third one too. Yeah, I think it's right. They're rotating around the center. So now I need to figure out the scale. The scale for each of, like for the first one, the scale is obviously 1, and it's right. It's gonna just fit into the width that I provided here. But for all the others, I would need to scale them because they're getting smaller. And the ratio that I need to scale them is actually dependent on the golden ratio itself. And it's gonna be, so on each step, there's gonna be some different scale. Scale equal, and I believe it should be an exponential function, so it's gonna be math-po something raised to the power of I. So because I0 on the first step is going to be just 1, and it fits me fine because the first one should be scaled just 1, just as it is. But the next one should be bigger. And this should be probably this phi. I'm not using this scale yet. So I need to scale my container now. I think they're getting bigger now. And I believe I should get the reverse one, so they get smaller. It actually fits. Is it actually? I'm kind of surprised it works. Okay, so let's do the 7. Yeah, I think it's right. So now we put each square exactly on this spiral we just drew with our arcs. So we are rotating every single one of them and then scaling them according to the golden ratio raised to the power of the step we are at. And it's kind of cool that it works. It's actually kind of magical. There's actually a meme about that, right? Someone in the chat gotta find out from the Adventure Time meme. Okay. Algebraically, okay. So it works. It's actually kind of surprising and kind of cool, but it just works like that. So now we need to rotate this whole thing. And how do I rotate this whole thing? So I need to so my container gotta be rotated. If I just do the rotation for my container, like this container, and actually before we do the rotation part, let's just switch the get block with the get river. With the get river, I'm gonna move it here, so we actually see the sprites add stuff. So instead of get block, and well, magically the sprites have been just connected into the spiral because each of them is just an arc and they are scaled, and I believe the arcs are drawn, the river sprite is drawn in the way that this is a bit more narrow than this, and then it just fits perfectly into the whole routine. So it's actually the sprite built with the, the spiral built with the sprite now, and it's kind of cool. Get in there, close. So now I want to rotate this whole stuff, but if I try to rotate, yeah, it rotates around the leftmost top corner, which I don't really like. I want to rotate it from the center, and for this I would do this container pivot set. So now it's rotating around its center. It actually kind of looks like a spiral rotate now. So I only need to move it now. So I need to move it back to its origin. Yeah, I think I need more than 7 steps, like maybe 20. And I could start, the wonderful thing about this equation, I could start with a -10. And this means I'm starting back, like zooming out. So now it's rotating, it's kind of cool, but if you pay attention here, it's rotating, but it's not changing its place. To do that, I need to rotate it and scale at the same time. So not just rotating this thing, I would also need to make a scale here. And I would need to do this. And I believe it should be also exponential, just like the one we just did with the squares. It should also be exponential. So what's going to be here? It's going to be again math. Oh, still going to be the same. You just need to normalize the same value, but to which power? This, just use this time. It's not this pi, it's this p. So this time doesn't work. I think I need to normalize this time by dividing it with math pi divided by 2, because we moved with those steps there. Yeah. Yeah, well, because we have the finite number of steps, it just gets out of the loop. So now it's actually being scaled and rotated at the same time. But we see, and this is funny to see this red square falling into the abyss. So it's kind of a cool spiral. It's not perfect, you could see here, it doesn't fit perfectly into the arcs, but it just works. And actually the same goes for the website. It doesn't fit perfectly. If you just put your cursor here, you could see that it's jumping around slightly. So let's put the city back there too. So I had this river and I had this city. Or did I? I didn't have, okay, let's have this city. And then add city to my spiral. I think maybe like this. I think I could just have 2 of them from the beginning, just the river and the city. And then I'm gonna add the river and I'm gonna add the city. And then I need to scale the river here. Something is wrong, container is not defined. Where did I use this container anyway? Okay, container river. So it's much like diffs in CSS. I just need to make some wrappers here. And this was the get river part. And the angle and scale should be at the top. City. Just replicating all the stuff for the city. And then container river, and then the same goes for the... Not sure if I need this. Should be. So now we have the river. I should also have the container city. I don't have it yet. What if I just replace it here? Yeah, we're gonna see the city, but I want to see it on the other way. Did I miss it? Container river, container city, adding everything. Okay, I need to add the city. So now we have the river and the city. Let's make the time run slower. And I've added those because I think container river, gotta scale it a bit. Scale it, river, scale it. You just make river a bit smaller, because if I scale it, for example, like this, it's gonna be real close. It's almost like outside in the next loop. So yeah, and just to fit the river between the houses, I think this works pretty good. So we actually kind of make it already. Of course, I could tie this one to the scroll now, and instead of just being time, I could just tie it to the scroll. Then I could remove the last ones. So when I actually rotate, I would bring back the last item to the first place, and it's gonna be an infinite thing. So yeah, but it's kind of, the way it's built is simple. It's just a couple of arcs, and then we put the sprites on those arcs, and then we just rotate the whole thing, and it just works. It's kind of, even though in some ways it's complicated, kind of like this animation and like how it's made. I wonder how the original developer came up with this. Where did he got the idea from? Those arcs he built or something? Yeah, I have part of the river probably. Maybe it's like this. So you have to know the exact thing. And also they have some shadows and clouds. So let's add some clouds too. And leave it at that. Just add in some clouds. Clouds, and then I need the sprite for my clouds. Did I have it anywhere? Probably not. These are the shadows, by the way, because houses have some shadows. And these are the clouds. Okay, I need to have the size of this thing. It's gonna be, whoa, it's not even, you can't even divide it by 4 things. All right, anyway. And it's not square. Turned out to be a bit harder with the clouds part. Whether they did it different way, the clouds, I'm not sure. I think not. I think but you have to know the size of the sprite. Let's get this. And then I need to have this get clouds thing. Well, something is wrong. City clouds is not defined. It's just clouds. Yeah, now we have clouds. Maybe clouds should be transparent. I actually need this. Yeah, obviously they have different kind of clouds, like more different textures, but we have them. Maybe scale them a bit too, just like I scaled this part. Container river, container clouds. Yeah, they gotta be a little bit smaller, and then we can move them differently to put them in a different container. But I think that's it. And when we add in lines, maybe I should make them more subtle. Add lines. Yeah, like this. Now the clouds more beautiful. Oof, I think that's it. I'm not gonna tie it to the scroll and all this stuff. It's kind of easy already. The hardest part we did here. And it's beautiful. It's beautiful how some of this kind of simple looking animation actually have a lot of math inside of it. Make an infinite loop. Okay, well, let me just spend 2 minutes on this. If I can handle it in 2 minutes, we do that. If not, not. I'm not speaking Russian, so more people can understand me. I want to speak Russian, just the Russians will understand me. It's not bad, but... And then I have still this river that I had here, and this square, something that have been added. Yeah, it's better now. How do I make it infinite? Okay. So at some point, when the zoom in for some section is already... No, I'm not gonna make infinite because I will need to change all this stuff a bit. I will need to make an array, and then I will just need to handle that array. And when I'm like on some steps, I would have another array like update lines. Instead of just adding lines, they're gonna be another loop update lines, which is gonna be just measuring if the line is already deep inside there, and if it's kind of deep, it's gonna just make it first instead of being last and just move it there. I'm not sure the Pixy handles that. I think we just need to delete the last one and then add the new one at some point. And it's a simple procedure when all the textures are loaded already. So yeah, it's kind of a bit more complicated than I thought in the first. Ooh, yeah, hope you like that. I'm gonna keep refreshing this part. Oh, I can just do... Here's an infinite life hack. Here's an infinite life hack for you. Yeah, it's infinite now. Kind of. All right, it's been a hard one. Lots of math, lots of hard things for me. I hope you like that one. If you do, support me. I'm gonna try to do those each Sunday, and I'm still planning to do short videos as well. So maybe I'll miss some Sundays, but instead I'll do some short videos about the animations and the front-end part and everything. And if you're interested in something, just put something under the comments, and well, like, subscribe if you wish to. I'd be glad, I'd be happy if you do this. Yeah, infinite refresh, that's true. I will make that infinite thing though after the stream. It's just that I'm trying to fit everything into 1 hour, and I spend a lot of time playing with those numbers, so I don't have any more time to play with the infinite part. And I don't streams to be that long. Yeah. So I hope you guys having a great day. I'm wishing you a great day anyway, and I hope it's gonna be a great one. Say something kind to some people that you love, and see you on the next Sunday. Have a fantastic